Hey everybody, welcome to my YouTube channel Coding with Trees. Today we are going to see balance a binary search tree. Problem of 26 June Liquid Challenge. In the problem statement, we are given a root of a binary search tree and we are required to return a balanced binary search tree with the same node values. If there are more than one answer, we can return any of them. A binary search tree is balanced if the depth of two subtrees of every node never differs by more than one. In this example 1, we can see the given binary search tree is not balanced. But these two versions of it are balanced because the difference between the left subtree and the right subtree in case of node 2 is 1. So the approach to solve this problem, there are two. You can use in place to transform the given binary search tree to a balanced binary search tree, or you can use an array to store all the nodes in an ascending order. That means from the smallest element to the largest element. Let's take this example where we have 1, 2, 3, 4. So let's say you have 1, 2, 3, and 4. Node 1, 2, 3, and 4. This given example is not balanced because the right subtree of 1 is 0, but the left subtree of 1 it has 3 nodes, so the difference is obviously 3, it's more than 1. To make it balanced, let's take an array. For example, array, let's call it I, and then we'll store the element from smallest to largest. So 2, 3, 4. So 1, 2, 3, 4. Now from this array we just made, let's reconstruct or build a new balanced binary search tree. So to do that, we'll take the middle element. Let's say 2 is the middle element. Then it depends, can either be 2 or 3. So let's in our example take 2. So 2 is the root node in this case. So at the left of 2 we'll have 1. At the right of 2 we'll have 3. Then when 4 comes in, 4 will be at the right of 3. So the left subtree of 2 is 1, the right is 2. So the difference is 1. For 1 is 0, 0. For 3 it's 1 at the right and 0 at the left. For 4 it's 0 and 0. So the difference between left subtree and right subtree of 4 is 0. The difference between left subtree and right subtree is 1 for node 3, 1 for node 2, and 0 for node 1. So this is a balance binary search tree, or BBST. If you consider tree as the root node, you'll have almost the same configuration. So you'll have tree as root, 2, 1, and 4. So you can see every node has the difference between left subtree and right subtree is less than or equal to 1. So let's try this approach to solve the problem. Let's dive into the coding. To solve this problem, using that approach I just explained, we need two helper functions. One is the traversal method in order. Traversal, that's to store the value of the nodes from smallest to greatest. So in the ascending order. So we'll have, let's say, the root, or let's call it node. Then you have the array itself. We call it shorted array nodes. Let's say root name though. What we'll do for in order traversal, we traverse to left, then root, then right. So let's take first if node is null, we return. Since it's a recursive function, then we'll traverse to the, we'll just copy the function set of typing. You will traverse to not left, to the left, plus array nodes, then we'll add and now node dot val, then just call it root. Simple. So we'll add the value, then you traverse to the right. We'll just copy this function, hit typing. So when we keep it simple, traverse to the right. So this is pretty much it. So the element will be inserted in ascending order, meaning we'll leave from smallest to greatest. And the other function is to build a new or create a new balanced binary search tree. So BBST, or let's call it balance BST. Build or create. Almost the same amount of letters. So for that one, we'll have the array. Let's call it in order. That's the list of array. Actually, it's shorted array for simplicity's sake. Shorted array, and then we have the start and end. Why do you need start and end? Let me explain you. You can see here we have this sorted array. If you consider 2 to be the root node or the middle of the array, then the start will be 0, and the n will be length minus 1, or in this case 3. So what will we do? We just pass the left side of mid to the function and the right side to the function to build it. So next time when you come here, we'll take this one as root, then build, so on. So that's how it goes. That's why we are having start and end. So if start is greater than end, return. That's the impossible case scenario. So the left sub tree will be create, balance, balance, BST, BST, have shorted array. The start will remain the same, but the end will be mid minus 1. And the right side will be from mid plus 1, mid plus 1 to end. Then let's create a node. The node will be new tree node. Take 3 parameters. The first is value. The value is shorted array at mid. We have left sub tree and the right sub tree. And then you just have to record node. Here let's define shorted array nodes will be a list. Then let's call it in order function first. Let's reverse function. We'll pass it. Take root and then short array nodes. Then after this, you can just call create balance BBST. Create balance BST, where it takes certain arrays nodes and then start is 0 and length is length of shorted arrays nodes. So assign that value to insert or root return root Let's try if there is no typos or syntax error. Invalid syntax. Oh, okay, so Python you don't need new. Oh, how did I write it? Maybe typos. Oh, wait. You need self here. Self. 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 Self is actually a equivalent to this. It's a pointer. What do you mean not? Oh, haven't defined mid. Mid is the middle. Should start plus end. So to avoid overflow, I just use start plus end minus start divided by 2. Data division. So this is the code. I had some, I have to debug some of it, so it was taking a lot of time to debug it. But the problem was here. I have to stop at len -1. So not from len. That was the mistake I made the typo in the code. So that's why it was out of bound. But now it's not. Let me zoom into it. I hope you can see it. So now it's okay. You can run. So let me just explain it all over again. Go briefly about it. Here, this in traversal, in order traversal is used to store the element in a sorting order from smallest to greatest using in order traversal. So that we'll have here, in this case, 1, 2, 3, 4. That example. So after that function, we have this create balance BST. This function is used to create the a or reconstruct the balance tree. So we have here mid is used to find the middle of the array, and the left side will be all the element to the left of the element selected, and the right side will be all the element to the right of the value selected. So node will be constructed using the current element you have, and its left will be the return value from the left tree, and the right value will be the value returned from the right recursion. So we just return node. So as you can see here, we define a list that will hold the element used in order traversal to store them in increasing order in search arrays nodes, whatever name, and then the root will be the element returned from creating the balance tree. So the root will be the middle of the array. So that's pretty much it. Let me submit. The time complexity of this is O of n, and the runtime and the space-time complexity will be O of n. So consistency is the key. See you tomorrow. Oh, what a funny joke. The code always have this I'm out of the words. Anyway, so thank you for subscribing, and please share, comment, and give a thumbs up. Peace out.